Okay, for question 5, you have over a long period of time is found that the amount of sunshine on any day in a particular town in a span has been 6.7 hours and standard deviation of 3.1 hours. Okay. So, and question asks you to find the probability that the mean amount of the sun over a random sample of 300 days is between 6.5 and 6.8. So, question never mentioned about the distributions, so that you cannot say, this is binomial, Poisson, or you cannot say this is normal, unless you apply a certain theorem to confirm the distributions. So let's see this question, you only have mean, you only have standard deviation. So you can see that the n is equal to, right, 300. Yeah, so 300 is more than 30. So from this you may able to form a distributions by using the random sample, right? The key marks there, the keywords there is a random sample. So from here we have a normal distributions, apply, and CLT 6.7, the mean, and you have the sample radius is 3.1 square over n, right? So this is your distribution by apply center limit theorem. So if you want to find the p between 6.5 and 6.8, right? So do the same things, you will do the standardized, right? 6.5 minus 6.7 divided by 3.1 square root of 100, right? So another side do the same things, right? Sorry, I have limited space because I had done this through my mobile, and another side will do the same. So you can simplify this equation, right, to form a z in between. Let me clear first. Okay. So you will find the z is in between p negative 1.117 and z is between 0.559, right? So this is a z that you need to find in between here, the probability. So if you continue to do this, right, you may able to simplify this one become 0.7119 minus 1 minus 0.8679, right? So simplify some more, you will get 0.580. This is approximate value. So you use the approximate value to find the probability by using the normal approximation and by apply the CLT, right? So this is for question 5. And part 2, give a reason why it is not necessary to assume that the daily amount of sunshine is normally distributed in order to carry out the calculation in part 1. This is the question. So you may apply the thing that you had learned in last week, or you may say like that: it is not necessary to assume that the daily amount of sunshine is normally distributed, because the sample size n is large, n is equal to 300, and the center limit theorem states that for large n larger equals to 30, the distribution of sample x is approximately normal, right? So you can use the similar sentence to answer the question. not must be equal. I mean, not must be 100% same, but must be equivalent. Okay, so this is a question that your past year 2004. Uh, we don't know this kind of question will come out again or not, but you can prepare for it. Right. So for question 5. Okay. For question 6, the random variable x has the distribution binomial 12 and 0.4. NP given. Find the probability that the mean of a random sample of 100 independent observations, okay, of x is greater than 5. Okay, this question, the keyword is random sample. So when you see this kind of question, you may need to do the approximation. But don't confuse with the approximation that you have did in the paper 5 step 1. So catch the keywords random sample, and you have a certain way you do it in the step 2. Alright, so clarify by yourself and divided it properly by yourself that which one is step 1, which one is step 2. So they are the overlapping things that happen in between these two. So catch the keywords. Okay, so for example 6, the keyword still the random sample. Alright, right. So for question 6, this is binomial distributions originally, and okay, let's start. Okay, if you want to calculate the binomial, you need to calculate same things. If you want to do a approximation, binomial originally 12 and 0.4. Right. So in the step 1, if you want to find mean is MP, right? MP is equal to 12 times 0.4, right? So you have 4.8, and your variance will be MPQ. You have 4.8 times 0.6, you have 2.88, right? And don't forget this is a random sample, right? Random sample, be careful about this. So your new distributions will be normal distributed because n larger equal to 30, right? And 4.8, and your variance will be 2.88, right, over 100, right? So this is your distributions. Okay, so if you want to calculate the probability for the next part, right, for the following part, then you need to use the parameter for these distributions, right? So now we proceed to calculate the requirement of the question. X is greater than 5. Okay, so for P larger than 5, and we have a P Z 5 minus 4.8 square root of 0. 0.0288, right? And you have a P Z larger than 1.179, right? And if you proceed, if you want to calculate this one equal to this is important, so you need to show that this step is important, although it's like a very simple step, but it's important. right? And you can continue and calculate. You should able to get the answer is 0.119, right? So this is for the approximation from a binomial distribution to a normal distribution by using the random sample, right? Question 6.